Hey everybody, it's me again. I'm not sure what's happening to me, but part of me has water spilled on me and my arm is gone, and part of me has ripped, my hand is now ripped off. Alright, so last week we talked about severe weather. Talked about severe thunderstorms, cumulonimbus clouds. We learned that about 10% of thunderstorms become severe, and to be considered severe, a storm has to have either 1-inch hail, winds of 57 miles an hour or greater, or contain a tornado. We talked about the difference between watches and warnings. Watches means conditions are ideal for a thunderstorm. Warning means there's a thunderstorm happening. Take cover. This week we are going to focus on tornadoes. And I love to study tornadoes in the springtime, especially in May, because this is the month where more tornadoes occur than any other month. In the United States, we experience far more tornadoes than anyone else in the world. Well, why is that? Well, think back to, making my papers a mess here. Think back to the lesson we did a few weeks back on air masses. Okay, so air masses in the United States, we have cold, dry air coming down from Canada. We have warm, moist air coming up from the Gulf. And then we have the Rocky Mountains to the west. And so geographically, we are just set up to have more tornadoes. No other countries have geography like we do. So this bar graph right here shows you that the average number of tornadoes we have is 1,293. We have more than any other countries, as I said. The country that has the second highest is Canada, and they only average about 100 a year. So we have a lot of tornadoes. You go to other countries, you talk about tornadoes, they're not really familiar with them like we are here. So tornadoes have occurred in all 50 of the United States, even Alaska and Hawaii, and they've occurred in every month of the year. Okay, winter months, January, February, we have little tornadoes. Definitely most common in the spring, primarily in the month of May, and then it kind of dwindles into the fall and down into November and December. Okay, greatest risk of tornadoes, if you look at this map, this area right here is called Tornado Alley, where we have more tornadoes and more severe tornadoes than anywhere else. That kind of dark gray region around Tornado Alley and then off the west coast of Florida does have a greater risk. And you can see we're kind of like right on the borderline. Excuse me. And then the New England states, west coast, tornadoes do not happen very often, but they have experienced them, like I said. Now, focusing just on Michigan. This is something we would have done in class, but we don't go there anymore. So this is a map from last year that I saved. So this shows you tornado data in Michigan from 1950 to 1999. And the actual number was 832 tornadoes during that time frame. So this is color coded. Counties that have had 30 or more tornadoes are red. Counties that have had 25 to 29 are orange, 20 to 24 yellow, and so forth. So what I want you to see here is that we're one of the counties that's red, but also the bottom of the lower peninsula is where most tornadoes happen in our state. Okay, not many happening up there in the UP. Why the heck is that? Well, what do we need to have a tornado? We need to have a severe thunderstorm. In order to have a severe thunderstorm, we need rising warm air. We are warmer down here than up there in the UP, so we are more likely to get rising warm air, more likely to experience tornadoes. Now, scientists don't actually know specifically what triggers a tornado. What we know is that we have to start with a severe thunderstorm. We have to start with a cumulonimbus cloud. So we have updrafts and downdrafts within that cloud. And then at the top of the cloud, we start to get horizontal winds. So these side-to-side winds. And as those winds are blowing horizontally, as we have updrafts and downdrafts, it triggers that rotation, which triggers that rotating column of air, which can become a tornado. Most damage caused by a tornado, of course, are from the high-speed winds. Occur most commonly in Tornado Alley, as I said, but they can happen anywhere. So when we look at tornado on radar, that's not radar. Scroll up here. What meteorologists or weather people look for are things like this. So this is a single thunderstorm. supercell thunderstorm. And when you look at radar, greens and blues are rain, and then yellow, orange, and then down to this color, magenta, almost black, and then this even gets white, is severe, severe weather. This feature right here is called a hook echo. And this feature right here indicates that there is rotation in the clouds. Now, can we actually see a physical tornado on radar? We cannot. But if a meteorologist sees this, they will issue a tornado warning because there is rotation and there could be a tornado. Okay, there's another example of one right there, the hook echo. And they're usually going to form in that lower left corner. Tornadoes move generally in the same direction, which we'll get to here in a minute, which is why you see the hook echo forming where it is. All right, so tornadoes are classified on what's called the Enhanced Fujita Scale, or EF scale. And the EF scale looks at not only wind speed, but also looks at damage to classify tornadoes. Usually what we have around here are EF zeros, EF ones, like this one right here. The strongest tornado we've had here was an EF4, but it hasn't been since the 1960s that we've had one like that. So here's an EF0. Damage caused by an EF0 would be something like this. So if we had a tornado around here, most likely this is what you'd see. Okay, some of the siding is gone, some of the shingles are off the roof, not a big deal. An EF1, okay, still a pretty small looking tornado. But with an EF1, your wind speeds are getting stronger. You're now over 85 miles an hour, and you're gonna start to see damage more like this. So we've got some trees down. Okay, there's more damage up there to the roof of the house. And then an EF2. Okay, a little bit bigger like that. And what you actually see when you see the dark of the tornado is actually the debris and the dirt that the tornado is picking up. Okay, damage with an EF2, you're gonna start to see some second story damage. This is why you shouldn't be upstairs during a tornado warning. You wanna make sure you're on the first floor, or better yet, in the basement. An EF3, okay, now getting a little bigger, is going to start to remove the second story of your house. EF3 has wind speeds over 135 miles an hour. A few years back, we had an EF3 tornado touch down in Dexter, which is just north of Ann Arbor, and this was the exact damage that they saw. Second story of homes being removed. EF4, okay, now we're getting much larger, and we're going to see damage like this. Okay, the homes are pretty much flattened. You can see that the trees, the bark is just gone. The leaves are gone, the bark is gone. It's called being debarked. So that's damage that we would look at for an EF4. And then a 5 is when wind speeds are over 200 miles an hour, and that results in complete destruction. And this is an EF5. Okay, you can see the path right there, the dirt path where the tornado moved through. There's a better look at it. The homes are completely destroyed, completely flattened. So in an EF5, you would need to be in your basement, you would need to be in a storm shelter, and even then, you're at risk for being injured or possibly killed. Okay, so here's another example of EF5. I mean, look at the cars. That was a hospital. Okay, that kind of explains why we don't want to be in cars during a tornado. This is the central room in this person's house. So for tornado safety, we talk about going in the basement or going into a hallway or a bathroom or something in the center of your house. Well, here's what's left. So that gives you a good reason why you'd want to go there. I think this is crazy. This is an old picture. It's black and white. This is called a record that you play on a record player. And the tornado actually made this record go into this piece of wood. It kind of looks like a telephone pole, which is crazy. Okay, EF5s can do things like that. This is actually somebody's basement. So down in the basement, and there's obviously some flooding going on there. Okay, and that's it for those pictures. When we talk about tornado movement, like I mentioned already, tornadoes move counterclockwise in the northern hemisphere. Okay, we can move counterclockwise, so opposite direction of the clock, and tornadoes move generally toward the northeast. So from the southwest toward the northeast. So if you see my lovely picture here, okay, that swirl is the tornado, and then the bald guy is a storm chaser. The X is where the tornado is heading. So being a storm chaser, if you know which way the storm is going, which is 99% of the time toward the northeast, then you know that if you stay in the southwest corner, you can get pretty close to the tornado without being injured. Now, do they always go that way? They don't, which is why sometimes we see storm chasers are injured or killed by tornadoes. Okay, watch versus warning. Okay, a watch means that conditions are ideal for causing a tornado. So sometimes it's crazy because it might be like a warm 90-degree day, or you're outside playing, we have a tornado watch. What the heck? That is crazy. But those days set up perfect conditions for tornadoes because it's hot, warm air is rising, those cumulus clouds quickly build up into cumulonimbus, and we can possibly get tornadoes. And then the warning means that a tornado has been physically spotted or indicated on radar. So a storm tornado spotter has seen the tornado, or like I showed you earlier, we get this hook echo on radar. They'll issue the warning. What do you do in each situation? The watch just means to watch. You don't have to hide in your house. You can go outside and play. You probably shouldn't go to the beach or go out in your boat, but pay attention to the weather. A warning means you need to take cover. You need to go in the basement. If you're me, you put your kids in the basement and then you go outside.